Okay, in this video, we're going to talk about how to solve trigonometric equations using the unit circle. So it is very important that you understand the unit circle, that you know you have it memorized, and that you know the patterns. And if not, you need to go back and watch the video on memorizing the unit circle first, because that'll be vital for this. Okay, looking at our first example, we're asked to solve each of the following equations for x values between 0 and 2 pi. So they're going to give you a domain that you're going to be looking in. Okay, so the first thing we're asked is the cosine of x is equal to negative square root of 3 over 2. So what x value, what angle on my unit circle has a cosine value that is negative square root of 3 over 2? Well, if you know the unit circle, and remember on the video I said that the first quadrant was the most important, I know that in quadrant 1, angles that have a square root of 3 over 2 for my cosine value are going to be this first one here. And that is going to be pi over 6. So the pi over 6 angle has square root of 3 over 2, comma 1/2 as my coordinates, where this is cosine and this is sine. So this is almost what I want. The problem here is I have this negative, so that doesn't work for me. The other thing I told you can memorize is all students take calculus. So cosine of x is going to be positive in the all quadrant and in the cosine quadrant. That means these two quadrants will have negative cosine values. Why? Because x is my cosine is my x value, and I'm going left, so we know those are negative. But all of my angles will have a 6 on the bottom. So I can say the x values that satisfy this are going to have a 6 on the bottom, and I know there are 2 of them because they're going to be in this quadrant. So if this is pi, then I have one that's a little bit under pi because it would be this angle. It would be the reflection here. So if this is pi over 6, it would be this one, which is just under pi, which is going to be 5 pi over 6 because that's just under 1 pi. So I have 5 pi over 6, and then I would have this angle here, which is just going to be just a little bit more than pi, which is going to be 7 pi over 6. And those are the two angles that have a cosine value that is negative square root of 3 over 2. Okay, let's look at this example. This is tangent. So again, you do have to know your tangents. Okay, and I'm going to draw another picture here because I drew that one and I filled it out and I don't really have a lot of room. So for the square root of 3, that's going to be this angle up here. That's going to be my pi over 3. Okay, now the coordinates for that is 1/2 and square root of 3 over 2. And if I put sine over cosine, because that's what tangent is, and I simplify that down, I would get that the tangent is square root of 3. So I know that my values of x are all going to have 3's on the bottom. These are the patterns that I showed you in the other video to help you use the unit circle. And so again here, this is all students take calculus. We want this one to be positive, so I'm definitely going to use this pi over 3 here because it's positive. And then I need to figure out what other quadrant is tangent going to be positive in, and that's going to be this one. And that would look like this. Okay, and so that one is going to be a little bit more than pi, but it's going to have a 3 on the bottom. So that's going to be 4 pi over 3. And those are the two angles that produce a positive square root of 3 for my tangent. Okay, looking at this one here, we're asked for the sine of x is equal to negative square root of 2 over 2. Now this one's a little bit easier because we know that our pi over 4 angle here has coordinates square root of 2 over 2. So the sine and the cosine are the same on this one. So for some people that makes it a little bit easier. So I know that all of my answers are going to have a 4 on the bottom. This is negative though. Again, everything in this quadrant is positive. All students take calculus. I want sine to be negative. So in this quadrant and this quadrant, sine would be positive. So we are looking for the angles in this quadrant and this quadrant. And again, this is pi. So this angle here, this pi over 4, would be a little bit more than pi, which would give me 5 pi over 4, because 4 pi over 4 would equal pi. So I need to go just a little bit higher. And this quadrant is the quadrant that almost reaches 2 pi. So we're not quite to 2 pi. We have a 4 on the bottom. That's going to be 7 pi over 4 because 8 pi over 4 would be 2 pi. And so those are the two angles that give me a sine value that has a negative square root of 2 over 2. Okay, we're going to look at a couple more. In this example, again, I give you the same domain here. But when you see something like this where sine x is not by itself, you really just want to manipulate that to get it by itself. So I'm going to subtract my 1, and I'm going to say 2 sine of x is equal to negative 1, and then I'm going to divide by 2. So what I really have is the sine of x is equal to negative 1/2. So this becomes just like the other problems, and it's asking me what values of x have sine values that are negative 1/2. Remember, sine is y. So which ones have y coordinates that are negative 1/2? And again, if you know just the first quadrant of the unit circle, you're okay. Because I know that pi over 6, which is this angle, has coordinates square root of 3 over 2, 1/2. This is sine, the y value. So the only problem here is I want it to be negative. It's positive here because all students take calculus, but I want it to be negative. Now you can use these, or you can go, I know that's my y value, and so y is negative when I have to go down. So it would be negative in this quadrant and this quadrant. And so the x values that are going to make that negative are going to have 6's on the bottom, because these angles will all match. This one, and this one will all have the same coordinates. The signs will be the only thing that's different, okay? They'll have the same numbers here, but the signs will be different. And so in this quadrant, I'm a little bit more than pi again, so that's going to be, that is going to be 7 pi over 6. And in this quadrant, I'm almost to 2 pi, but not quite, so that's 11 pi over 6. And so those are the two angles that give me a negative 1/2 for my sine values. Okay, this one, same idea. I want to get cosine squared by itself, so I'm going to add my 1. I'm going to get 4 cosine squared x equals positive 1. Divide by 4, and I'm going to get 1/4 here. Now, this is cosine squared. You can look at it like that, or you can look at it like this. Sometimes it's easier for people to see it where the cosine is in parentheses squared. Either way, I'm taking the square root. So what I'm going to get is cosine of x equals plus or minus the square root of 1/4, because when we square root something, we put plus or minus. So simplifying that, the square root of 1/4 is 1/2, and I have a plus or minus. So what I'm really solving is I'm saying, well, cosine of x needs to be positive 1/2, and cosine of x needs to be negative 1/2. So which angles give me positive 1/2 and which angles give me negative 1/2? Well, that's pretty easy because that takes care of our positive and our negative. So that's going to be 4 angles. It's going to be one from all 4 quadrants. But I need to know for which value is my cosine, which is my x value, going to be 1/2. And that's going to be my pi over 3 angle up here. So all pi over 3 angles. So my positive 1 would be here. So x would equal pi over 3. And then it would also be here because cosine is positive. And so that's going to be 5 pi over 3. And then to get my negative 1/2, I would be in these 2 quadrants. And that's going to be it's going to both have 3's on the bottom the same way. Okay, this one's going to be a little bit under pi, so it's going to be 2 pi over 3. This one's going to be a little bit more than pi, so 4 pi over 3. And all 4 of those angles produce an answer, a value that when I plugged it into this equation would give me 0 because that's squared, okay? All right, one other thing you really need to know is your reciprocal trig functions. So the sine of x is equal to 1 over cosecant x. If that's true, then cosecant of x is equal to 1 over sine x. And when you see this function, you're going to change it to this if you're solving equations, okay? Cosine of x is equal to 1 over secant. So secant is equal to 1 over cosine. Tangent is 1 over cotangent, or sine over cosine. We use this a lot, but it's also 1 over cotangent. So cotangent is 1 over tangent, which is the one we're going to use primarily, but it is equivalent to cosine over sine. So you have to know these to be able to solve equations when you see one of your reciprocal trig functions. Notice that it's not sine and secant, which a lot of people think because they both start with s's. This is sine and cosecant, cosecant and sine, okay? Secant and cosine, cosine and secant. So just be careful with that. Okay, we're going to look at 2 examples for this, and just for fun, I did change the domain here. So instead of 2 pi, it's pi. So we're only looking at our unit circle from 0 to pi. We're not going to be using any of this for now. If that was 2 pi, we would. Again, If I see secant and I'm solving, I'm going to change it to 1 over cosine. So this is going to be the square root of 2 times 1 over cosine x equals 2. And you can rewrite this as square root of 2 over cosine x, which is probably how I would probably skip this step and go straight here, but if you need to see this, that's fine. And I want to get cosine by itself, so I multiply both sides by cosine. And I have square root of 2 equals 2 times cosine of x, and I'm going to divide by 2. And so what I have is square root of 2 over 2 equals cosine x. And now, again, it looks just like the other problems we were solving. So we're asking what values of x, or what angles, doesn't have to be x, I could have used theta here, what angles have a cosine that's square root of 2 over 2? Well, all students, remember we're not using these two because we're stopping at pi, and so we want cosine to be positive. It has to be in this quadrant, and square root of 2 over 2 is going to be my pi over 4 angle. So my only answer for this one is pi over 4. We would have another one if I had 2 pi here. Okay, let's look at this example. In this example, we're going to change cosecant to 1 over sine x, and then we're going to work on getting sine by itself. So we're going to subtract the 2. And I have 1 over sine x equals negative 2, and I want to multiply both sides by sine. Okay, so this is just basic algebraic manipulation here. So I have 1 equals negative 2 sine x. Divide by negative 2, and I get negative 1/2 equals sine x. So what we're asking is what angles have a sine value or a y value that has a negative 1/2? Well, in this case, look at my problem here. All students. So sine values will be positive here and sine values will be positive here. They would be negative in this quadrant and this quadrant, but unfortunately those two quadrants were taken out of our options. So this answer actually has no solution. For the domain we were given, there is no values, no angles in this domain that will give me a negative 1/2. I do have angles that would give me a positive 1/2 in both quadrants here, but I don't have any that's going to give me a negative 1/2. So we would just write no solution. Okay, I hope that helps. And again, if you need to, go back and look at the video on memorizing the unit circle. That is super, super important to be able to use this. Okay, see you in the next video.